I'm going to demonstrate how to use an interactive simulation that looks what happens if we have a container filled mostly with water with the vapor space containing both water vapor and air, and then we raise the temperature. And so several things are happening simultaneously. As we raise the temperature, we raise the saturation pressure of the water. Water also expands as we raise the temperature, and so the liquid volume increases as we raise the temperature. And then the gas phase, as we decrease the volume, we also increase the pressure. As we raise the pressure, more of the oxygen and nitrogen can dissolve in the water. But as we raise the temperature, less tends to dissolve. And so these are competing factors. And what we have is the simulation just shows the container, and what we can vary is the fraction of the container, which is 1 liter, that's liquid water. And then here shows where the oxygen is located. This is the gas phase, and then this amount of oxygen is dissolved in the water, and here's the equivalent things for nitrogen. The simulation's on the LearnChemE site. Here's a link to the simulation. So let's look at the simulation. Okay, so let's look at a case where we have more water, less air. Now, as we raise the temperature, we can see the water volume is increasing, vapor volume is decreasing, and so what happens is the pressure starts going up, and the pressure is going up for the several reasons mentioned. And what happens is the pressure can actually get quite high as we keep doing this, because only a small amount dissolves, but you can see more dissolves at this higher pressure, even at the higher temperature. Not quite half of the oxygen originally present has dissolved. And we keep increasing the temperature. Look how high the pressure has gotten until, in this case, the container has a limit of what pressure. And this happens in real systems, that if we fill autoclaves too full of water and raise the temperature, we can usually, of course, autoclaves have a pressure relief valve. We usually spring that pressure relief valve. So we're looking at ideal gas law, saturation pressure, solubility, and water volume expanding, all affecting the behavior here.